Okay, so as of now, we have seen basic data types in Java, that is int, char, float, and how to use them, how to print them, and how to assign values to them. So let's look at a little more advanced data type or data structure rather. So what we look into is something called as arrays. Now in C you must have come across arrays before. So we know arrays basically you can say as data structure which can hold elements of the same type. So if I want to hold, let's say for example, I want to hold marks of a student. So I will create an array of marks. I can hold as many different marks in it as I want, but all of them should be of similar data type. So in this example, I've taken integer. That array name is marks, and I represent this array by square bracket. So open square bracket, close square bracket. Now in Java, how do we define an array? Is in this format. You give the data type first, right? So the integer is the data type. Then give the name of the array, whatever you want to call it, and then start a square bracket and close a square bracket. Now here what we have done is we have only created an array of the name marks. We have not as of now assigned how many elements is this going to store, right? So that is not fixed right now. So to do that we have to use a keyword called as new. So what we do here, marks is equal to, marks is the array that we have created here, is equal to new is a keyword. So we're saying create a new array of the type integer which can hold four elements, right? So here we are declare create allocating memory required for four elements. So this line is only creating telling the compiler that we are going to have an array of the type marks. We are not assigning any memory, we are not telling it how many elements does marks have, anything of that sort. We are only saying we are going to have an array which will be called as marks. In this line, we are saying marks is equal to create a new array of the type marks, that is assign the required memory. Each element will be of type integer and there are going to be four integers in it. So 4 into 32, that many bits will be allocated for marks. Fine. So this is the line where memory allocation for the array happens. Now we can assign elements into this by index. So like any normal C array, this also starts on 0 index. So marks of 0, I'm giving the marks as 10. Marks of 1, I'm giving the marks 20. Marks of 2 is 30. Marks of 3 is 40. Now remember, we have given only 4 elements. So I can have only 1, 2, 3 and 4 elements here. And so this is how we access individual elements inside the array. Right. Now let us say I want to find the average of the marks. So I can say marks of 0 plus marks of 1 plus marks of 2 plus marks of 3. So basically I'm taking 10, 20, 30, 40. That is nothing but marks of 0 will be 10 here. Marks of 1 will be 20. Marks of 2 will be 30 and marks of 3 will be 40 because that is what we have given in these four statements. Divided by 4.0, I put an F here to indicate I can get a floating point number. So if you remove the F from here, you have to make this as double or you have to make it only 4 and call it integer. Fine. So just to make it a floating point, I put an F here. So the final answer is going to be floating point. So if you remember and data type transitions, this was one of the rules that we had seen before. Fine. So now this is calculated, you get the average marks allocated here. So let me just run this much and see uh, how do I get the output. If you want to print individual these array elements, we can also print it here in the println by accessing marks of 0, marks of 1, so on and so forth. And so let me just run this much and let me just only see one this print, and remaining will concentrate again later. So the average marks is 25.0. That is the first line that we have printed here, right? Now the array need not be only integer. Here we have created array of type integer. I can also create array of type double. So I have double temperature. So the name of the array is temperature. Type is double. I have not allocated how many temperatures to hold. So temperature is equal to new double. Now here I am giving uh, 3 as the number of elements. So I am saying create an array of the name temperature new array. That element new is indicating we have to create a freshly, and it's of the type double, and each number of elements to be held in the array is going to be 3, right? So I can assign access to this temperature of 0, 20.1, temperature of 120, 30, any number you want. Note that we are not putting an F here because we have not marked it as float. It's a double, so F is not required. I can access any of these three values by simply accessing the index value. The temperature of 0, I'll be able to print whatever is assigned here, right? So let me just run this and see what I get. So I get 20.1 as the solution here. So this is what we assigned to this, right? Temperature of 0 is 20.1 and we got the answer as 20.1 here, right? Fine. So now this is when we are storing a linear set of elements, only one dimensional array. Now, in case you want, let's say, store a matrix. Like matrix has, if you remember, has rows and columns both. So when you want to store data type of that format, where you can have a matrix of elements, you can go to a two-dimensional array. And so the initialization part is same. So integer, I am calling the array as two-dimensional, and I'm having two square brackets now, right? To indicate I'm going to have one set of rows and one set of columns. So this basically meaning I'm going to have an array of arrays, right? So let me just put it in a little more graphical point of view, or let's say mm, right. So this is like I'm having one array. This is my first what we have created, one dimensional array, an array of elements, right? Now let's say I want to store multiple such arrays. I want to have two array and to have third array, all these array, and I want to store all this in a separate array. So this becomes my two dimensional array. This is one array, this is second array, this is third array. Like that I have three arrays in this. So that becomes my multi-dimensional data structure. So here I have three rows and each row has four columns. So one, two, three, four, four columns. This is basically a 3 cross 4. You can say a matrix if you're dealing with matrix, or you can say three arrays with four elements each, depending on what how we are using this data structure. Right? So what we have created here, we have said data type is integer. The name is 2D to just to signify a two-dimensional array. We have put two square brackets, one square bracket indicating it's an array of first dimension, create and first dimension array, second indicating a second dimension. So I'm saying an array of more arrays, right? I can initialize it in the same line by calling the new keyword new integer. How many rows and columns? Two rows and two columns. So this is my rows. That means how many arrays and how many elements does each array have. This is my columns. This is basically I'm creating something like this, two separate arrays. So I have two elements, element 1, element 2, element 1, element 2, and this is my first array and second array. So this is my two rows and these are my two columns, right? So you can have any number you want. So basically I am creating an array of four elements internally. For memory point of view, I have one, two, three, four elements, fine. So four elements multiplied by the data type, which is int, so 32 bits. So I need to allocate memory for this much of data. So that's what the compiler is required to know. Right? So that is my two-dimensional array. Right? So how do you allocate values to this? It is you access them just like any other array by index. So when you say two-dimensional 0 of 0, let me rewrite that array here. Mm, okay. Uh, okay. So if this is my array and these are my this is my first row, this is my second row. So 0 of 0. So this is my 0th row, this is my first row, 0th column, first column. So 0, 0. This is my first element, two-dimensional 0 of 0. 0 and 1. This is my 0, comma 1. This is second element. 1 0, this is my 1, this is my 0. So first row, 0th column, that is this one. First row, first column, that is my this element. So basically I assigned 1 2 3 4. This is 0 comma 0, 0 comma 1, 1 comma 0, and 1 comma 1. And that's how the assignments have been done. So this is how you access elements in a two-dimensional array, right? So and when you print it out, you can print it out by accessing any of the elements once you've assigned it, right? So let me just run this much and see the output before you continue. So you can say Java's second element is 2. So you can say the second element is what we assigned here, right? So now we see double as a data type. You can also have float as a data type. So if I'm creating float two-dimensional array, the space does not matter. I can give space here. If you want to allocate the values in the same line, right? Now what we did here, we created an element with no, we created an array with no values and assigned the values later. You can also assign the values in the same line. So what we've done here, we said floating point data type two-dimensional array is equal to open a flower bracket. Now because this is a two-dimensional array, it is going to hold array of arrays. So create a sub-array. So another flower bracket and create one array 1.0, 2.0, close flower bracket. So this becomes one array, fine, comma second flower bracket for second array 3.0, 4.0. Second array is closed, and you can close the array. So this basically has same thing like this 2 cross 2. So two arrays, one array and two array. Each array has two elements. So either we can create it like this, create an array without elements and then assign values to it, or you can create an array in the same line as it is, right? So this is valid for one dimensional array also. So if I want to create one dimensional array here and assign the values in the same line, I can do that. New, let's say I will create a temp array, and I can directly say new uh, is equal to new uh, integer of type 4. This is also allowed. So then I can access them using my index values. Okay, why is it saying it's a problem? Migrate type to int. Have I used it before? Okay, sorry, I have to allocate an array here. Sorry, int array, right? So yeah, fine. So that is one way of doing it. Or I can say int temp array of 2 is equal to, I can allocate it here itself 1 comma 2 comma whatever values I want to give, call it an array, right? So there are three ways of doing it. One, you create only the name and then call the new keyword and with the assignment of how many elements are required in it and then assign the values. This is one method of allocating it. Second method, you create the array and in the same line call the new keyword also, right? So generally you will see this being used more, right? Because this reduces this, you need not have one line with this and one line with this. You can create both of them in the same line. So this is what you will see most commonly being used. Data type, the array name is equal to new, the data type and how many elements, and then you can assign values to any element you want. A third type is when you want to statically give the values to array directly here. So I can say temp array. I need not give how many elements here because while declaring itself, I am assigning the number of elements I want. So it automatically becomes an array of 4 elements. 1, 2, 3, 4. Right? So that's three different ways you can create an array in Java. Right? So that is valid for any data type, int, char, float. So I have created a char data type here, char name single dimensional array is equal to, I've created four characters J, A, B, A. Alright, so you can note the single quote. So it's a character array. So single quotes indicate each element is a character. Right, so one character, two character, three character, and four characters. I have not given the count here because that is taken care by the static allocation that we are doing here. It automatically takes four elements. And I'm printing out the same character array here, the name array, name of 0 plus name of 1 plus name of 2 plus name of 3. Now notice that I have given a empty string here. That's because I want to treat them as characters, right? So if I don't give this empty string, each of them will become an ASCII value because then the print statement assumes that each character is an ASCII value because unless and until it does not notice that I'm printing a string, it will not treat this as string. So just as an example, now as of now I can say it's printing Java. If you remove this empty string from here, I'll just show what happens by removing it. So if I only try to print them as it is now, I'm just printing plus 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 and I run this. And see it's now it's printing some number 290, which basically is the sum of ASCII values of each of them. JAVA, each ASCII value is taken and it's added up because now it treats them as ASCII numbers and not as characters. So if you want to treat them as characters, make sure it is the plus sign is given a string here. So it treats this also a string. So then the string plus string, the value is retained. It's not converted to ASCII. It is retained as the character itself. So now it will print Java if I add the string value here. Right. So that's how you treat the arrays. Fine. So different ways of taking arrays. So basically remember the three irrespective of data type, three ways of working with it. The data type of the array, name of the array, and the square bracket. Depending on it's a single dimensional, two dimensional. If it, you can also create a three-dimensional array by creating three set of brackets. I can have this is basically three-dimensional array. And so one array of arrays. And so right now not required. We will not be dealing with 3D arrays, so it's okay. Then you create use the new keyword and allocate how many elements you want and allocate the elements. And second way is you create the array and also allocate the memory in the same line. Most commonly done. Third way is you statically allocate the values to the array in the while creation itself. So you need not mention how many elements to be used here. You can directly allocate the memory here, allocate the values here. So please note if you try to access elements beyond what the array is created for. Right? So as of now, it is not throwing any error. Uh, but when you try to execute it, you might not really get the expected output. Sometimes it will work. This is not a very recommended way of working with it. Right? So it sometimes it works, but you can't be very sure that it is going to give you the required output every time. And so let me try to print it here. Let's say I want to print marks of 5, even though I've created only 4 element array. If I try to print marks of 5, and let's see if it prints. 1, 2, 3, 4. Okay. Okay, something else is wrong here. This is okay. Okay, so it is a runtime error. So it array index out of bound exception. So this it will not tell you when it is running when you compile the code, but when you execute the code, it will say you're trying to access a value which is out of bound, array index out of bound. Right, so it is beyond what you have created. You have created an array of 4 elements and you're trying to access array of fifth element of the array, which is not the right thing. So that is something that so it is giving you a suggestion saying look at the fifth line saying you have created the array here. So see, so you can change some. It's just a prompt saying you try to modify here. Where did the actual error happen? 11th line. So you can say it is mentioning here the 11th line. 11th line is where we access the fifth element. Even though we have created array of only four elements, we access the fifth element in the array, and that's where it caught up with the exception saying array index out of bound. What are the exceptions? How are they handled? We'll see that. I mean, we'll come to that a little later in the syllabus. But just so be careful that even though it is not a compilation problem, it did not throw an error while you're I mean, but when you run it, it'll be a problem. Fine. So unlike other errors, like if I leave a semicolon, it will immediately tell you that it is wrong. But that will not happen when you exceed the array values, right? So a little careful when you write these things. Right, that's about it in arrays. So please go through it. We'll be writing programs using arrays later. And now in the index values, you need not have a constant always. I can also use an variable. I can say int I is equal to 0, and I can access the value using I also. Like I is here, then I can do I plus plus, and then I can do I here. So that's also allowed. This is what we'll basically do when we do loops later. So we'll be accessing the elements index using variables. So I can say I is equal to 0 and then say marks of I, where I gets replaced by 0 here because I is 0, and marks of 0 becomes 10. Then I plus plus I becomes 1, and then I re marks of 1 becomes 20, so on and so forth. Fine. So I can use index as variables also, which is the general way or recommended way of doing it when we will follow loops later. Okay. So hope that concept is clear. Any doubts in that you can clarify in the class. So, but make sure you go through the video and please try this codes out. All these codes are being shared in the Google Drive that I have shared through email. So uh, go through it. Right. Thank you.